This is the second block of topic 7. In this lesson, you're going to be able to write a precise definition of a triangle and then apply what is called the triangle inequality theorem, which we've talked about before, so this really should be mainly a review today. So if I was to ask someone what a good definition of a triangle is, a lot of times students will say it's a three-sided figure. Well, that is a definition of a triangle, but it's not the most precise one. If you look at these two figures here, they have three sides, but they are definitely not triangles. So a more precise definition, one that we need to make sure that we understand, is that a triangle has to be a closed figure that has three sides. So number 1 on your notes, what is a good definition of a triangle? It is a triangle is a closed figure or polygon with three sides. So we can't just say it's a three-sided figure because of these two figures that we have as drawings here. So can we make a triangle out of just any set of three lengths given? And we've talked about this before, but I hope that this activity will make a little more sense for you today. And so you're going to need to be logged in to your Agile Mind account, and we've practiced doing this at the beginning of the year. So if you've forgotten that, just go back to that lesson. But you will need to go to russellville.agilemind.com. And remember, Agile does not have a D in it. And then your username will be your first name, your last name, and 24 without any dots. First name, last name, 24, no dots. And it should be your RSD website. Your RSD password, I should say. All right, so what you're going to do is we are in topic 7. So once you go to My Courses in Geometry, you'll come over here to topic 7. And under Exploring, you'll go to this activity entitled A Triangle or Not. And so the way that you're going to do this is in this first column you have side links. And so to do this activity, you're going to have to click on a set of side links like the 6, 6, and 2. And you're going to take these links of 6, 6, and 2 and try to make a triangle out of them. So it can be a little bit cumbersome at times. You've got to make sure that you connect dot to dot, and then you can move and you can rotate to match up dot to dot. So it may take you a little bit of time to get this process down, but if you get it together, it'll tell you that yes, you formed a triangle. So you already know the answer to the first one. 6, 6, 2 can form a triangle. So what I want you to do is go ahead and pause the video here and go ahead and go through this activity on Agile Mind, and then unpause when you have all of those answered. Okay, so you can look at the results of your investigation and see if they are correct by looking on the key that I have here. So we did 6, 6, 2 together, and that was yes, it forms a triangle. The first one that was a no was the 4, 2, 8 links. That is a no. And then a 2, 4, 6 is a big no, and 4, 4, 9 is a no. So other than those three, all of those others should have been a yes. So let's look at why that happened. So on the screen here, you can see what you should have tried to do with the 4, 2, 8 triangle. You can see that you can never quite get those 4 and 2 sides to match up. And so that's why that did not make a triangle. When we look at the 2, 4, 6, this is what happens. The 4 and the 2, in order to meet, go just into a flat line with that side that was 6 centimeters. And so that tells me I can't form a triangle either, because those all become collinear points. And so what we can use here is looking at the segment addition postulates. If we know the part plus part equals whole, then that means we had to have a segment, which means all three of those points are collinear, which obviously means we can't make a triangle. So what I want you to do with your results, you can look at number 3, where you're explaining why some of the side lengths of the combinations did not form a triangle, and you could just put in your own words that your two sides wouldn't meet or they would fall flat to make a segment. But then on number 4, I want you to write a conjecture about the relationship among the lengths of the sides of a triangle. So these that work to make a triangle, why is it that they worked? So pause the video here and see if you can put that in your own words on number 4. So your conjecture is something that we can prove, and so it's really called a theorem. It's the triangle inequality theorem. So you could have said it in your own words, but let's look at it written in the official way. The triangle inequality theorem states the sum, which we know means to add, of the lengths of any two sides of a triangle has to have what relationship to the length of the third side? So hopefully you always saw that anytime you added two sides together, it had to have a certain relationship to the third side. And so is it greater than, less than, or equal to? Well, we saw when it was less than that those other two sides would never meet. And we saw when it was equal to, it just fell flat into a flat line. So obviously the sum of any two sides of a triangle have to be greater than the length of the third side. That's why it's called the inequality theorem, because of that greater than relationship. So you can pause this in order to get that written down if you'd like to. And while you're pausing it, go ahead and write down this last problem that is on my notes here, because we need to talk about this. This is something that will be on your homework this evening too. To wrap up today's lesson, we're going to look at this question. It says, if two sides of a triangle are given to be 4 centimeters and 7 centimeters, what must be true about the length of the third side? So I'm going to kind of highlight our notes here to kind of look at this question in a little more in depth. So I have it written down here and asked you to pause and get it written down as well. And I just have some numbers down here below that for us to just kind of use as a thinking process. So remember, we know that the sum of any two sides has to be greater than the third side. So if these two are my two smaller sides, then that means that the third side couldn't be the sum of these, right? It can't be equal to. So it can't be 4 plus 7 is 11. I know the third side cannot be 11 because two sides cannot add to get equal to the third side, right? So also, would 12 work? Well, 4 plus 7 is 11, and 11 is not greater than 12. So we can knock out these numbers as well. None of those would work for the third side. You can't have a 4, 7, 11 triangle, a 4, 7, 12 triangle, a 4, 7, 13, and so on, because these two sides would not add up to be greater than the third side. So that kind of thinks about, well, if these are the two smaller sides, but we don't have any way of knowing for sure these are the smaller two sides. So this could be the largest side, the 7. 4 would still be one of the two smaller ones, right? So let's think about this. Well, we know that a side can't have a side of 0. That doesn't make sense. But let's try 1. Can we have a 1, 4, 7 triangle? Well, no, 1 plus 4 is not greater than 7. So 1 would not work. 2, 4, 7 still doesn't work because 2 plus 4 is not greater than 7. 3 doesn't work either, right? Because 3 plus 4 is equal to 7, right? So if it's an integer, it'd have to be 4, 5, 6, 7, 8, 9, or 10, right? But could the third side have a decimal in it? Well, of course. So would 4, 7, 10.9 work as a triangle? Yeah, 4 plus 7 is 11, and 11 is greater than 10.9. So we could go all the way up to, but not equal to 11. Same thing here. We could have a 3.1 as a side, and this still works for a triangle because 3.1 plus 4 is 7.1, which is greater than 7. So I can go as close as I want to 3. I just can't go all the way down to 3. And so what we find is that we can have a third side anywhere between, and this is how we would write that algebraically. This shows that x is greater than this number, while at the same time less than this number. So we have to be greater than 3, but we have to be less than 11. Any number in between 3 and 11 works. I didn't put equal to bars because we're not saying the third side can be 3, because we know it can't be. That cannot be a triangle. And we're not saying it can be 11 because that cannot be a triangle. But any number in between 3 and 11 would work for the third side. So I want to show you an easy way of how you can figure out what that number has to be. Look at the numbers that we were given, 4 and 7. There is something we can do with 4 and 7 to get 3. And what is that? Hopefully you can see it's subtraction, right? 3 is 7 minus 4. Well, what can we do with 4 and 7 and get 11? Hopefully you can see that's just adding 4 plus 7. So the third side of a triangle always has to be greater than the difference of the two sides given, but less than the sum of the two sides given. Okay, so the third side has to be between the difference and the sum of the two sides that are given. That's how you come up with these numbers right here and not have to go through this process every single time. All right, good luck on 7.2.